What is a neural network? How does deep learning enable AI machines to learn and think? A neural network is a complex network structure composed of multiple nodes, or neurons, which is used to simulate the human brain's neural system. By learning and optimizing, it can extract useful information from input data, and achieve applications in artificial intelligence fields such as image recognition, speech recognition, natural language processing, and so on. Analogous to the neural system in the human brain, a neural network is also composed of many units, which simulate the connections between neurons in the human brain through the connections between these units. Each neuron receives information from other neurons, and processes this information by certain rules, then passes the processed result to the next layer of neurons, finally producing an output result. This simple neural network consists of three layers: the input layer, the hidden layer, and the output layer. Among them, the input layer receives external data input, such as image or sound data. The hidden layer processes the input data and generates a new set of feature representations, which can better reflect the characteristics of the input data. Finally, the output layer maps these features to the final output result. In this neural network, each neuron processes the input data and passes the processed result to the next layer of neurons. Specifically, each neuron has a weight vector, which measures the importance of different features of the input data to this neuron. The neuron multiplies the input data by the weight vector, and passes the result to the activation function for processing. Finally, the output value of the neuron will be used as the input of the next layer of neurons. In this way, a neural network can process input data layer by layer, gradually extracting useful features, and finally producing the final output result. Of course, this is only a simple neural network. In practice, the structure and layers of a neural network can be more complex, and the specific structure will vary depending on different tasks. The history of neural networks can be traced back to the late 1940s when the prototype of neural networks, called perceptron, was introduced. Perceptron was a simple model that could simulate the human nervous system and process data such as images and sounds for classification and recognition. However, perceptron had some limitations, such as only being able to handle linearly separable data and being powerless against complex data. Over time, neural networks have gradually developed and expanded, introducing many new structures and algorithms. In the 1980s, scientists proposed an algorithm called backpropagation, which could more efficiently train neural networks and enable them to handle more complex data. In the 1990s, neural networks began to attract attention from academia and industry. There is a story that the US Air Force attempted to use neural networks to recognize enemy aircraft and friendly aircraft. However, when they tested the neural network, they found that it could only recognize the outline of the enemy aircraft and not its direction. This is because the neural network had not seen backward-facing aircraft during its learning process, and therefore, could not recognize them correctly. The learning process of neural networks is similar to the human learning process, requiring continuous practice and feedback to adjust its cognition and judgment. In neural networks, data is the foundation of learning. Neural networks continuously adjust their parameters based on the data, making their output results increasingly accurate to the actual results. For example, in image recognition, the input of the neural network is an image, and the output is a label representing the object contained in the image. When the neural network is initially learning, it does not know how to distinguish between different objects, so its output results are often incorrect. However, with continuous input of data, the neural network gradually learns how to distinguish between different objects by adjusting its parameters, making its output results more and more accurate. The learning process of neural networks involves continuously inputting data, forward propagation, back propagation, and gradient descent to adjust its parameters, gradually minimizing errors, and learning correct knowledge and skills. As computer performance improves, the size and depth of neural networks also gradually increase. At the beginning of the 21st century, a revolutionary change occurred in neural networks, known as deep learning. Deep learning is a machine learning method based on multi-layer neural networks that can handle very complex data, such as images, speech, and natural language. A large number of intelligent products have also emerged as a result, such as ChatGPT, Midjourney, Notion AI, and various other intelligent software, which have further fueled people's enthusiasm for artificial intelligence. Overall, the development of neural networks is full of innovation and exploration. Now, neural networks are continuing to grow and develop, and there are undoubtedly more surprises waiting for us to discover in the future.